There we go. Sorry for the language in the chat here, but yeah. Wow, this is the most hilarious ever. It's kind of funny.
See the fire right there by Big Bear.
It's about the volcano that erupted earlier this year.
Let us mark this day with remembrance of who we are and how far we have traveled. Let it be told to the future world that in the depth of winter, when nothing but hope and virtue could survive, that the city and the country, alarmed at one common danger, came forth to meet it. America, in the face of our common dangers, in this winter of our hardship, let us remember these timeless words. With hope and virtue, let us brave once more the icy currents and endure what storms may come. Let it be said by our children's children that when we were tested, we refused to let this journey end.
You can expect is 6 or 7 seconds.
As big as a 15 megaton city killer nuclear bomb.
If we ever announce that there is one that's going to hit, and we don't have an answer to what are you going to do about it, you're going to have public panic. It's only a matter of time before the next big one hits us. Technology is available today so that when the Earth is in fact threatened by an asteroid, we can move it out of the way so that it doesn't hit the Earth.
Checking out traffic this morning along the Kew Gardens.
Oh my gosh. This is fun. This is fun. Fun. Look at the quality, boy. This is funny. Oh my gosh. Oh, there's an alert about my video. I could go.
Hustle and congestion. With all the close calls and near misses that people all over the world have come to accept as the normal level of risk in everyday life. But on that day, high overhead and behind the sun, what no one saw coming, what no telescope on Earth was able to see against the blinding light, was an asteroid big enough to destroy an entire city.
Move the chat down, move my face. Okay, there we go.
From behind the sun.
Oh, now it's buffering. Come on. Oh, I got this. Just gotta click it again. Here we go. There we go. We're fixed. Sort of. There we go.
It shot past, less than a third the distance to the moon, and nobody saw it. Until 3 days later, when the rock emerged from Earth's shadow into the night sky, going away.
It looks like the Earth just dodged a bullet. Actually, it was an asteroid. Scientists say it blew by last week at a distance they describe as a close shave.
The airline industry would call this a near miss. Scientists who study asteroids and comets called it a problem.
The threat of asteroid impacts on the Earth is very real. We know that throughout history this has happened. The craters we see on the moon are examples of the kind of impact history that the Earth has had. But it also happens very rarely. So it's a very unusual kind of hazard. It's a hazard in which the risk in any one year is very low, but it does happen, and if it really did come about on our watch, it could end civilization.
These cosmic bullets originate on the far side of Mars, in the main asteroid belt, where a bracelet of celestial debris circles the sun. Millions of rocky fragments, building blocks of a planet that never quite came together when the solar system was formed. What's often depicted as a busy cosmic junkyard is actually more like a big empty speedway. The rocks are far apart and moving very fast, ranging in size from pebbles to boulders to rocks the size of Mount Everest. Occasionally, the tug of Jupiter's enormous gravity drags an asteroid off course, causing it to crash into another asteroid. Some veer away into new orbits that cross the paths of Mars, Earth, Venus or Mercury. Another ring of David
Mic
called
drop.
the Oort cloud is the source of most comets, which are big, rocky ice balls that orbit the sun and cross the paths of the inner planets.
You guys are all believing a bunch of...
All the inner planets and our moon
Oh,
bear the scars of
clunky.
numerous asteroid and comet impacts.
We do get hit all the time by pieces of debris from asteroids and comets. In fact, 40,000 tons of cosmic debris plummets into the atmosphere every year. We see them every night as shooting stars. They don't hit the Earth very often, but when they do, clearly it isn't just going to be a matter of a shooting star seen in the sky. So it is inevitable. It's only a matter of time before the next big one hits us.
Even small rocks can make a big impression. In 1908, about 2,000 square kilometers of Siberian forest were instantly flattened as an asteroid exploded near the Tunguska River. The impact site was so remote, researchers had to mount a wilderness expedition just to find the
This is
place.
so fake.
When they arrived, there was no crater. Paintings, based on eyewitness accounts, described a fireball. A horrendous explosion in the sky.
Didn't actually come crashing down to the ground. It exploded maybe 5 to 10 kilometers up in the atmosphere, and that made a big blast wave in the atmosphere, and that is what did the damage.
All this was caused by a relatively small asteroid, somewhere between 50 and 100 meters across. Roughly the same size as asteroid 2002 MN, the one we couldn't see coming. Tunguska's 2,000 square kilometer blast wave would have leveled London. But as bleak as the thought of cosmic collision may be, there is at least a glimmer of hope.
One of the special things about the asteroid impact problem is that unlike the weather or earthquakes or other natural hazards, we, at least in principle, we could do something about it.
And when we know one's coming for us, our claim is that the technology is available today to stop it.
On the Earth, we've got active geology, we've got volcanoes, we've got earthquakes, we've got continental drift, we've got rain, we've got wind, we've got storms, we've got snow. All of those things erode away craters, and that, in some ways, actually fools us into thinking that indeed the Earth doesn't get hit as often as it actually does.
Counting craters on the moon and then estimating how often the Earth gets hit can be a pretty sobering exercise. One scientist who made that kind of calculation was astronomer Ernst Öpik, who published his impact estimate back in 1951. The general public, however, paid little attention to the science or the implications. But one individual who did take the issue to heart was Lembit Öpik, the astronomer's grandson, who got himself elected to Parliament.
My grandfather is the reason why I carried on in politics, what he initiated in science. In essence, he was a pioneer. He saw the danger of asteroid and cometary impacts with the Earth, and he had the courage to speak up about them. And he did that at a time when it wasn't really taken seriously, in the 1950s and 1960s.
After years of pushing and prodding, Lembit Öpik convinced the British government to commission a comprehensive scientific study of the asteroid and comet threat. The expert conclusion was, the threat is indeed real.
The government has set up a task force to examine the risk of an asteroid hitting the Earth.
Still, skeptical politicians might want to get on the bus and take a trip to the Natural History Museum. Ask any schoolchild who's been there recently, and you'll hear a fascinating and truly scary tale about what happened to the dinosaurs.
The dinosaurs were alive here. They were dead when this sediment was deposited, and this layer is one of the most unique layers in Earth history.
In 1980,
there's a bunch of
bull
Twinkies and boats taking
led Lewis and
rainbows.
Walter Alvarez to publish a theory that a huge asteroid or comet had hit the Earth 65 million years ago and wiped out the dinosaurs.
Sorry, this is just live factual comments, so, you know. This is interesting, but no. Not real.
There had to be a crater. There may be tons of dinosaur bones in these dry canyons, but where on Earth was the big crater? Just the kind of mystery a budding young scientist would love to solve.
When I went back to...
Off the coast of Mexico's Yucatan Peninsula, Dr. Alan Hildebrand investigated a huge gravity anomaly discovered by oil drillers back in the 1950s. Put that together with a semicircular magnetic anomaly, and you get a massive crater, 180 kilometers across, near a little village called Chicxulub Pueblo. Most of the crater is underwater now. Erosion and continental drift have covered the visible evidence. But 65 million years ago, this was ground zero.
This object would have fallen through the atmosphere in just a few seconds. Just going through the sky, it would have been brighter than the sun. As soon as it contacts the surface of the shallow sea in Chicxulub, of course, it starts propagating the shock wave down into the planet, and it keeps pushing into the planet, and it only gets stopped maybe about 30 kilometers down. The pressure wave would have traveled around the entire planet in the atmosphere. You could have heard the impact on the other side of the planet. The giant impact fireball rising out of the hole, it would have risen, say, 10,000 kilometers above the surface of the planet. Near the impact site, it would have been so hot, it would have evaporated the clouds and been hot enough to make the forest, even a green forest, begin to burn.
For Alan Hildebrand, finding that crater pretty much clinched the argument. Planet Earth had been all but sterilized by a rock the size of Mount Everest.
3/4 of the species of large animal life went extinct.
We have made the case. We've got the qualitative information and we've got the statistics to show that there is a very serious risk.
If you wanted to save planet Earth from cosmic disaster, where would you find people with all the right stuff to do the job? Well, Houston, Texas might be a good place to start looking. This town has that rarest of breeds, the space cowboy. Houston is home to NASA's Johnson Space Center, where rocket science is a way of life and astronauts learn their trade.
If you could roll me 90, then go down. I'll come in on my side.
Behind a swimming pool big enough to swallow an apartment block, you'll find a small research lab, where the rocket engine of the future is being built and bench tested.
Yeah, very nice. Question is, how big is the plasma going to go from here to here?
Dr. Franklin Chang Diaz is one of the lead researchers, as well as an astronaut with 7 shuttle missions under his belt.
And in fact, there was a time in one of my flights where we got hit by very tiny micro meteorites, perhaps, or some sort of orbital debris, which made little tiny dents or little craters in the windows of the shuttle.
Well, that tube is welded. Yeah, I did it. We already welded it. Yeah, I did it.
First-hand experience with rocks in space gave birth to a new idea and a dual purpose to Chang Diaz's work here. His rocket
this is fake news.
Long-distance missions to Mars, or as far away as the icy moons of Jupiter. But it could also be used to push a dangerous asteroid out of harm's way.
I am concerned enough to think that we need to not waste time arguing about it as to whether it's real or not. I think we need to move ahead and do the demonstration, because even if this is a threat which has a very low probability, all it takes is one, and we are history.
But before we can send a spacecraft chasing after a rogue asteroid, we have to know where to look for it. In the American West, if you drive across the desert to the White Sands Missile Range in southern
Okay, many times as NASA confirmed the end of the world. This is not real. Like, seriously, this is a bunch of poo.
Have tested everything from rockets to
those rocks cost. It's a bunch of perverters without money dollar cyanide.
Today, across the valley floor from the Trinity bomb site, the U.S. Air Force has installed one of the world's most advanced telescopes. This state-of-the-art technology was developed by MIT's Lincoln Laboratory as part of the Star Wars anti-missile defense system. These may not be the world's biggest telescopes, but they clearly are the best when it comes to finding deadly rocks in space. This is LINEAR, the Lincoln Near-Earth Asteroid Research Facility.
On a given night, when we scan the sky with this, we'll find perhaps 10 to 12,000 moving objects in the sky. Now, most of those are main belt asteroids, and as such don't represent any danger to Earth. But on the other hand, something like half of those will be brand new discoveries, and buried in there will be 1 or 2 near-Earth objects.
Because the Earth rotates, the sky is always moving overhead. To get a clear picture of an asteroid, you have to make the sky stop moving. And you do that with a telescope that can track or follow the stars. This way, you can take time-lapse pictures that isolate the blur of fast-moving asteroids against a crystal-clear sky. It then records these pictures like a TV camera
what
on
the
a
heck?
computer chip that has
Where are you
20
guys
times
getting
more
all your
detail than the
facts?
picture you're now watching. The linear computer deletes previously known stars and planets, leaving a less cluttered time-lapse sequence of the new discoveries. At the end of each night shift, Linear's thousands of new discoveries are emailed to the International Astronomical Union's Minor Planet Center at Harvard University. A team of only 3 scientists must cope with the avalanche of new sightings, searching for potentially hazardous asteroids or comets. Computers make a rough calculation of an asteroid's orbit, but it's up to Brian Marsden to estimate the level of risk.
They may be reporting 50 or 60,000 observations from one night, and it takes a while to get through that. But so we look first at the fast movers and see if there's anything interesting there. H is equal to sine delta. We do sometimes
all religions are one. R1. All anti-religions are one. You either have faith in something that builds positive character, or you don't, and your last name is Rockefeller or Worthchild or Morgan. What the? Oh.
5 shots in one night cover only a tiny segment of an asteroid's orbital path.
You can't solve for the orbit completely from that, but the fact that you're seeing motion over a half an hour or an hour, something like that, does allow us to
wait, what did I say? I'm
gonna for the orbit.
Refining the orbit gets complicated.
Wagyu? What the heck name is that? Wagyu.
Its trajectory was warped by Earth gravity. And scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, had to add that to their calculations.
Here's an animation I put together of the asteroid last year, which was discovered after it passed by the Earth.
An elite team of mathematicians and celestial mechanics is now working full-time on a computerized warning system.
What kind of name is that?
Orbit animation, you can see how when it returns out to the asteroid belt, the close approach to the Earth has changed its orbit. And it's no longer returning to the same place it started.
So Gary, did you put up anything else here that I missed?
Circle around the sun and come past us again.
No.
The NASA orbital mechanics team will have to adjust the calculation.
So you're gonna take my words, go read the Bible? Good job. Good job, man.
So
And that's what I did. Otherwise, he's otherwise busy, but you know.
See how close it came to the Earth. It went over the top, and how you can actually even see the bend in the trajectory. So it's a great example of how a close approach to the Earth, or in fact any planet, can be used to, or can significantly change in orbit.
To know where an asteroid is likely to be in the future, you need a model of the solar system. Mechanical models that show the relative motions of the sun and planets have been around since the early 18th century. They're called orreries. What the celestial mechanics at NASA had to do was create a new digital model. One that includes the gravitational attraction
Earth is square. L show.
And all the other forces that can affect where an asteroid might go.
You just compute what forces are acting on this particular asteroid from all the planets and many of the minor planets in the solar system, and then we can actually trace the motion of that object around the solar system for hundreds of years.
I think the Earth
for scientists, the acid
is
test
a
mathematics came when a strange new comet raced toward Jupiter. A stream of cosmic bullets that would shock and amaze millions here on Earth.
Potato. I think the Earth is the shape of a potato. A potato. Yeah, potato. I'm joking.
In the spring of 1993, the eyes of the world turned almost in unison towards a doomsday look like no other. From the far side of the solar system, it flew in a death spiral toward the largest planet. Gene Schumacher, his wife Carolyn, and their colleague David Levy had discovered an odd-looking streak of light that turned out to be a fractured comet. 21 large chunks of icy rock and cosmic dust heading towards Jupiter.
We knew we had something very unusual. It was so unusual we were a little unsure just what we were dealing with.
NASA asked Paul Chodas and his team to calculate the orbit and predict whether this new comet would actually hit Jupiter.
Again, it started off at 60%. Before long, wrong. It was 90%, and this was a year before impacts.
That's
As the impacts approached,
3?
we continued to predict not just the impact probability, which went very high, but where and when the comet fragments would hit the planet. And it was a prediction months in advance, and as we got closer and closer to the impact,
I think
I
that's
kept
3,
wondering,
right?
well, is the math right? Will this actually happen the way it was predicted?
A giant comet is on a collision course with Jupiter.
Everybody on Earth who was paying any attention wanted to see if the comet would actually hit Jupiter.
He's put up June 19th.
Ambitious mission to service the Hubble Space Telescope.
3 days from June 19th was the 22nd. We're still here.
NASA's
It's all
Hubble
fake.
Space Telescope
All fake.
set
All
its
fake.
sights on the planet. And the pictures of what happened next were truly stunning.
This is all fake. This was put up on the 20... Oh, no. On the 19th.
And then the impacts occurred. We were within minutes of getting the right
72
answer on the time of
hours
impact, and the location of impact turned out to be just right.
be.
Over the next week, 20 more fragments of the comet crashed into Jupiter. Some leaving scars as large as the Earth.
Bang on its cosmic schedule, the comet's first impact was recorded by NASA within the last hour.
Fragment G slammed into Jupiter, releasing an amount of energy equivalent to about 6 million megatons of TNT.
In the wake of SL9, a group of concerned scientists gathered in Italy for a brainstorming session. They created a brand new international organization called the Space Guard Foundation.
This is all fake. This was put up on the 19th. 72 hours would be last Friday. I am laughing.
Some people imagine that there are lots of astronomers out there scanning the sky looking for incoming comets and asteroids.
I did the math.
But that, of course, is not true. In fact, until recently, there was hardly anyone out there looking.
It's going to glow for about a half an hour and set everything on fire around it.
But whose job is it to defend planet Earth? Weapons scientists from the United States and Russia had already held a series of meetings and came up with their own ideas about how to deal with the impact threat.
Blow off some material, you get a reaction, and it's
the military establishment
72 hours is
created a whole lot of
3 days.
or at least concepts for
the date on this was the 29th.
And in the early 90s,
Okay. We're done. Okay, I'm gonna end this soon. The 19th was Tuesday. 3 days from Tuesday is Thursday. Is Friday, I mean, yeah. So, I'm gonna say it's not real. It's obviously not real either way, but no, not real. Nothing. Yeah. Tell the truth. Please like, comment, and subscribe, and be sure to share this. And I thank you all for coming to my stream. Thank you.